All right, in this video we are going to be using a calculator in order to find the exact zeros of a function. All right, so let's just jump right into it. We're going to do two quick examples in this video. All right, so in this first example we have f of x is equal to x cubed plus x squared minus 12x plus 12. And we want to find all zeros and write f of x as the product of linear and irreducible quadratic factors. So again, all that means, guys, when I say write it as a product of linear and irreducible quadratic factors is just, well, x minus 3 times x minus 1 times x plus 4. Those are our linear factors, right? They're all x to the first power. And when I say irreducible quadratic factors, that's just, well, let's say we find one linear factor. Once we divide by the linear factor, we are left with a quadratic. And when we use the quadratic formula, it gives us non-real roots. All right, then in that case, you would just leave it as the quadratic. Okay, because we don't want to have to write it with i's. We don't want to write out like, oh, x minus 3 times x minus 4 plus 2i times x minus 4 minus 2i. All right, we don't want to write that. So that's where the irreducible quadratic factors comes into play. So without further ado, and of course this says use a calculator, let's get to our calculator. Let's type this in, let's graph it, and let's use the graph to help us determine what the zeros of this function are. So remember to graph, we're going in, we're hitting y equals. These buttons up at the top are what we use for graphing. All right, I know this is just an app. It's going to look a little bit different than your calculator, but for the most part, it's very similar. All right, go in, type it out, x cubed plus x squared minus 12x plus 12. Then let's just go ahead and graph that, and let's just make sure our window is normal. So I'm going to use zoom 6. That's your standard zoom. It should go from -10 to 10 in both the x and y. All right, so I graph it, and I can clearly see here that I have 3 different zeros. I have one over here, and then 2 more that are kind of close together. All right, so we're going to use the calc function to help us find these zeros. We used the calc function of the calculator earlier on in the year when we were finding the extrema of the function. But now, yeah, we're going to use it to help us find the zeros or the x-intercepts. So I'm going to hit second and then trace right up here at the top again, right up in these graphing buttons. So I hit second calc. And then you should see 1 is value, 2 is 0, 3 minimum, 4 maximum. All right, obviously we're trying to find a 0, so hit the number 2. It says left bound, so go to the left of the 0. Hit enter. Then it says right bound. We'll go to the right of it. Hit enter. Yours will then probably say guess, so hit enter again. All right, my 0 tells me it's about -4.37. Yours might be slightly different, like by 0.001 or so. All right, so we don't really want to use that one. That's not really like a great number, right? Could I say, oh, maybe that's supposed to be -4.5? No, it's definitely not close enough. So that's an irrational number. While yes, it is a real number, it's irrational. Do you really want to go into synthetic division and use -4.37228? Probably not. All right, so let's check these other two. Maybe one of those is an integer or something we can use. So I'll hit second calc, and then again, I'm going to try to calculate a 0. Let's go over to this next one. So I'm scrolling right on the graph. Yeah, I'm scrolling right very slowly. There I am. All right, I'm going to go left of that 0, then right of it. Make sure that you're not including 2 zeros within it. Your calculator is going to get confused if you try to do that. So go to the left of it, go to the right of it, but not past the next one. Hit enter. Yours will say guess, hit it again. And now we're getting 1.3722. All right, again, not a rational number. So let's try it one more time on this next one. I promise you this next one will work. We'll go to the left of it. We'll go to the right of it. Hit enter again. This tells me 1.999. Yours should say 2. All right, hopefully your calculator says 2 or like 2.000000. All right, either way, that's 2. Okay, that number there is 2. So I got one of my zeros is x equals 2. Another way of using the calculator to help us quickly find zeros is let's just go to the table. So as long as our zeros occur at integers, the table is really useful. So I'm going to hit second table, and then we can just scroll through, and we're looking for where's the y value equal to 0. So just scroll through. Oh, look, when x is equal to 2, y is equal to 0. All right, great. That's my real 0. I'm going to go ahead and divide by x minus 2 now. All right, so I'm going to go back here. Oh, no, it deleted everything. Wow. All right, well, we're going to get back to it. I remember that my function was, luckily I wrote it down on a sheet of paper, x cubed plus x squared minus 12x plus 12. All right, that's my function, f of x. And then I just found one of my real zeros. Okay, one of my zeros was x equals 2. So great, I'm going to divide by the factor x minus 2. So I put 2, 1, 1, negative 12, 12. I'm going to hustle through this synthetic division. At this point, we should be good at it. 1, 2, 3, 6, negative 6, negative 12, 0. Good. If you didn't get 0, you screwed something up because the calculator told us x equals 2 was a 0. So if we divide by x minus 2, which should be a factor, we should get a remainder of 0. So now another way of writing f of x is I could write it as x minus 2 times, well, that's x squared plus 3x minus 6. All right, can we factor x squared plus 3x minus 6? No, we can't factor it. And right, the graph showed us that we're going to get some irrational numbers. So we got to use the quadratic formula. So negative 3 plus or minus the square root of 9 minus 4 times a times c. Let's see, 4 times 1 times negative 6 is negative 24. So 9 plus 24 all over 2. All right, that's negative 3 plus or minus square root of 33 all over 2. Can you simplify that any further? Unfortunately, you cannot. Okay, we cannot simplify that any further. Square root of 33, we can't reduce that at all. So that's my last two zeros are just negative 3 plus or minus 33, square root of 33, that is, all divided by 2. All right, so those are my 3 zeros of the function. Now for this, remember that tells me each of my factors is just x minus a 0. All right, so I could write f of x as f of x equals x minus 2 times x minus a negative 3. So x plus 3 plus square root of 33 all over 2. But does that look nice? Like, is that really going to look any better than what I wrote up here? Probably not. So really, when these zeros are irrational, I think sometimes it's probably just easier to leave it as an irreducible quadratic. All right, so just leaving it as x squared plus 3x minus 6. All right, let's just go ahead. Let's do one more quick example with this, guys. I had this example written out, but let's go with f of x equals x cubed plus 9x squared plus 28x plus 30. Great, I'm going to type this into the graph. All right, our instructions are the same. Let's find all of our zeros. So x caret 3, make sure you scroll over, plus 9x squared plus 28x plus 30. All right, I graph that. I can see one of the zeros. Let's just go and check the table and see if I can find another. All right. Oh, look. Wow, looking at the table, it tells me that 0 is x equals negative 3. And as I scroll through the table, I'm not finding any more. And remember, to get to the table, guys, it's just second and then graph. You see table right above it. So it looks like we just have this one 0 at x equals negative 3. All right, so we have a 0 at x equals negative 3. Again, you could use the calc feature on the calculator, but the table helps us out for this one. All right, so my zeros, well, I got one of them at x equals negative 3. Then let's divide by x plus 3 then. 1, 9, 28, 30. Remember, as we do this synthetic division, we should get a remainder of 0. And we did. Perfect. So now I could rewrite f of x as x plus 3 times x squared plus 6x plus 10 All right, x squared plus 6x plus 10. Sheesh, that's a 10 right there, guys. Sorry about that. 10. Even that's not that great. All right, 10. All right, can we factor that? Let's think what multiplies to 10 adds to 6. 5 and 2 doesn't work, unfortunately. Oh, man, that's too bad. Let's use the quadratic formula. Well, -6 plus or minus the square root of 36 minus 4 times 1 times 10 is 40 all over 2. All right, and we can clearly see we're going to get some non-real zeros. -6 plus or minus square root of -4 all over 2. That's x equals -6 plus or minus square root of -4 is 2i all over 2. So we get x equals -3 plus or minus I. So my zeros are x equals -3 and x equals -3 plus or minus I. There's my zeros. Again, I'm not going to write it out as, oh, f of x is equal to x plus 3 times x plus 3 minus I, x plus 3 plus I. All right, even though this is correct, it's kind of ugly. All right, so we're just going to leave it like this with that quadratic left as it is. All right, hope this helps you guys out for the homework. Best of luck.